We the team Cattlense from college and Kirkwood of College of Engineering and Technology Solapur presenting our problem statement title Image-based animal type classification for cattle and buffaloes. So, do you know India has over 300 million cattle, but the farmer faces a critical challenge accurate breed identification and early disease detection. Study shows that misidentifying a cattle breed can reduce the milk productivity by 15 to 20%, and delayed detection of illness can result in losses exceeding 10,000 per animal per year. Traditional manual methods are slow, error prone, and inefficient, leaving farmer without actionable insight. So here we bring our Catalans, AI-powered smart farming solution. With just a photo, Cattlense can instantly identify cattle breeds, detect early signs of diseases, maintain digital records of each animal. So Cattlense empower the farmers to make faster, smarter, and more profitable decisions. So the innovation and unique feature we bring here is differentiations of the breed, the productivity farmer we can use, the real-time image analysis, and it does also a user-friendly interface. So the target audience of our project is the small and large-scale farmer veterinary and livestock departments in the at last and dairy cooperatives and milk producers.
So let's now move on to the working prototype technical approach of our project. Okay, so Catalyst leverages advanced deep learning as well as computer vision technologies. We have used image processing, breed classification using CNN, and disease detection using also CNN with VGGNet and MobileNet. Uh, we have also used the data analytics, tracks growth, milk yield, and health trends for each animal. Here, the farmer opens the app. The app is built on the Flutter application. So after that, the farmer captures the image. So here we are using OpenCV and YOLO Vision. So the image processing is done using feature engineering. After that, our model works. Our model classifies the breed using CNN and detects the skin disease using CNN and VGG60. So also we also implemented the smart assistant in our app, which helps the farmer user to ask the questions, to ask the doubts. We have built this using Gemini API in the backend. So by using all these methods, our decision making is done, and the result is shown on the particular dashboard. So tech stack we have used is Python, machine learning, Flutter. We have trained this model on 2000 images, each image like each breed with its particular disease as well as it is a cattle or a buffalo. So let's move on to the working prototype of our project. Okay, so this is our working prototype of our project. So here as you are seeing this is a buffalo which has which has breed as Murrah. Okay, it has skin disease of ringworm, that is dermatophytosis. Our model also suggests let's diagnose or consult to a veterinary as early as possible. Okay, uh, so let's discuss about the feasibility and viability of our project. So Catalans is highly feasible and viable because India's large unorganized cattle population requires the technology-driven management. Farmers can access the app using smartphones without internet connectivity. Low cost deployment using AI models ensures scalability across villages. Integration with existing farm practices increases the adoption potential. So studies indicates AI assisted livestock management can increase productivity by 15 to 20% and reduce the veterinary cost by up to 30%. So as you see, here is our overall workflow of our workflow and architecture of our working project. So the feasibility are offline ability, transferability, robustness, and multitasking. And the viabilities are marketing, impactfulness, connectivity, and distribution. So, uh,
So let's discuss about the impact and benefits of this project. Catalans transform livestock management. First one, the smart decision. Helps farmer act before problem escalates. The second one, healthier cattle. Early disease detection reduces loss and improves welfare. Third one is increased productivity. Boost the milk yield and breed quality up to 20%. Digital records that enables data-driven farm management. Empowering farmers. which makes technology accessible even in rural areas. It does also offer us a saving, which includes lowers overall treatment and veterinary cost. It is also a reliability, which works in low light and noisy farm environments. It does. We can also scale this project across cooperative and states. We also can collaborate with the big multinational industries and share the insight. So here with our research and reference, we have researched around 20 to 30 papers for our project. We have got a reference also. We collected data set from Kaggle, Google. We also used models of GitHub, Zoos method, and case studies we had used as we had done surveys, research studies. We also used open source training multitask models. For processing, we had used cloud computing, and we do use computer vision, machine learning, and for integration, we had we had used and for video explanation, we are will had prototype which are already available in the GitHub. The detailed explanation of the project is provided in the following YouTube link. You can check it out here.